Today we shall discuss physics problem number 37. As usual, the statement is on the board. There are three cylinders A, B and C placed on two inclined planes. Inclined plane angle is theta with the horizontal. Now we want to find the theta minimum, that is this. See, as you diverge the planes, there is a possibility that these two will get separated and this will fall down into the gap. So without that is the case when this theta is decreased. So there is a minimum angle theta at which this equilibrium can still remain. So that angle theta we have to find. So in order to work out, we marked certain forces in the diagram. For example, this normal reaction, we mark it as R between the inclined surface and the two lower cylinders A and B. Let M equals, we take the mass of each as m, small m. Let M equals mass of each cylinder. Mass of each cylinder, we take it as n. N as the normal reaction. N equals normal reaction between A and C. Between A and C. Or it can be between B and C. B and C. That normal reaction let us mark as N, which is this normal reaction. N, here also N, it will be down on B, down on A. Then R is the normal reaction between, R equals normal reaction between the inclined and lower, or any of the lower cylinder, between A or B, and the incline, the respective incline. N dash equals normal reaction between the lower cylinder, between the cylinders. N dash, this is N dash. N dash, N dash. So N dash equals normal reaction between the lower cylinder, between A and B. Normal reaction between A and B. Between A and B. Now we come to the criteria at which the equilibrium will be disturbed. That is, whenever two bodies are in equilibrium, or whenever two bodies are in contact, there should be a normal reaction between the two. So, as to reduce this theta, at one stage, A and B will get separated. That is the time which this N dash becomes 0. The normal reaction becomes 0. At that time, that N dash normal reaction becomes 0. So, just before the system collapses is the equilibrium is broken. Just before the system collapses, n dash becomes 0. N dash, that is this normal reaction. Normal reaction between A and B becomes 0. So, if you find the angle at that instant, that is the minimum angle that we want. Just before the system collapses, n dash becomes 0. So, just assume that n dash is almost 0 and we work out the angle theta according to that condition. So, I will delete some part of the board so that we can continue with the remaining workout. We mark some angles on the board first. This ABC is an equilateral triangle, so this angle must be 60 degrees. This must be 60 degrees. Then the normal reaction R will make theta, because this is theta, so this must be theta. Also same others side also same R with theta. This is theta, so we get that. Now equilibrium conditions we apply. Equilibrium equations under the condition that n dash is equal to 0, the equilibrium conditions which are right. Equilibrium equations. Vertical equilibrium of C. Vertical equilibrium of C. C being this. Vertical equilibrium is maintained by normal vertical component of the normal reaction n. N sine 60 degree. N sine 60 degree. There are two n's, so times 2. Should balance the weight of this. There is no other external force on C. N 2n sine 60 degree equal to mg. Mg is the weight of each mass, which you can mark if you want. Mg, and mg. So, for vertical equilibrium of C. Then the horizontal equilibrium of A or B. Horizontal equilibrium of A or B. Horizontal equilibrium of A or B. Horizontal equilibrium is maintained by this. N has an horizontal component. R also has an horizontal component. So, weight will not come into the horizontal equilibrium condition. So, R horizontal components R sin theta, which is equal to n cos 60. N cos 60 is the vertical component. N cos 60 is equal to R sin theta. So, that is the horizontal equilibrium. So, this clubbing the two, we get 2 tan 60 degree. That is, when you divide, 2 tan 60 degree becomes mg by r sin theta. We get that relationship. Now, vertical equilibrium of the whole system. Vertical equilibrium of the whole system. For which this N is an internal force, because equal and opposite on both. Only the external force will maintain the vertical equilibrium. External force is on the whole system. This R is an upward external force. That is R cos theta, 2R cos theta. 2R cos theta is equal to downward vertical force is 3 mg. 3 weights are involved, 3 mg. So 2r cos theta is equal to 3 mg. We take it as equation, this one as equation 1 and this as equation 2. From the two equations, 1 times 1, if you multiply by 2, we can eliminate something, that is r can be eliminated from that. So you get mg by r sin theta into 2r cos theta is equal to 3 into 2 tan 60, 3 mg, 2 tan 60 degree times 3 mg, 3 mg. So tan theta, that gives us immediately the tan theta value. This tan theta equals 3 root 3, because we substitute, this is root 3, this is root 3 only, r will cancel, this is root 3, mg will cancel, so this is root 3, 2 also will cancel. After that, tan theta is equal to 1 by 3 root 3. That gives us the required angle. Theta equal to, theta is what we want, minimum angle, tan inverse of 1 by 3 root 3. 1 by 3 root 3. Theta equal to tan inverse 1 by, or theta equal to cot inverse. Theta equal to cot inverse of 3 root 3. So in trigonometric form, you can just give the answer like this. If you want the numerical answer, you can refer to the tables. Or theta equal is approximately 10.89 degrees. 10.89 degrees, or theta is approximately 11 degrees. So up to 11 degree you can reduce this angle. Below that, suppose you make it 9 degree or 10 degree, it will collapse. This system will equilibrium